In this video, we're going to look at how to use the distributive property with variables. Let's explore distribution. We'll use the expression 7 times the sum of 2 plus 3. First, we'll simplify the expression using the order of operations. And in following the order of operations, the first thing we do to simplify this expression is add 2 and 3. We do what's in parentheses first. 2 plus 3 is 5. And then the next operation would be multiplication, which is 7 times 5, and it simplifies to 35. Another way that we can simplify this same expression is by distributing. What that means is that I will distribute the number 7 to each of the numbers that's inside parentheses, which means I will distribute the 7 to the 2 and the 7 to the 3. So mathematically, that means I'm going to multiply 7 times 2, and I'll multiply 7 times 3. So my expression looks like this now. 7 times 2 plus 7 times 3. Following order of operations, I must do multiplication next. So 7 times 2 is 14, and 7 times 3 is 21. Lastly, I follow the order of operations and I do addition. 14 plus 21 is 35, which is my expression simplified. Okay, now we're going to model the distributive property using an algebraic expression, and we simply do that by taking our numeric expression that we used before and replacing the 2 in the numeric expression with the variable n. So we're creating an algebraic expression, 7 times the sum of n plus 3. Okay, so let's distribute the 7 to the n and the 7 to the 3 in parentheses. So I'm going to distribute 7 to n and 7 to 3, and I'm going to rewrite the expression as 7n plus 7 times 3, and I simplify 7 times 3 as 21. And I stop here because 7n and 21 are unlike terms, and I'm not able to add those two together. So my simplified expression is 7n plus 21. So let's practice a few more examples of the distributive property with variables. In the first example, I'm going to distribute the 3 to the x and the 3 to the 7. My expression is going to be 3x plus 3 times 7, and when I simplify it, it becomes 3x plus 21. My simplified expression is 3x plus 21, and I cannot add 3x and 21 together because they are not like terms. In the next example, I'm going to distribute the 4 outside parentheses to the 5 and the y inside parentheses. So 4 is going to be distributed to 5, and 4 will be distributed to y. And my expression is 4 times 5 minus 4 times y. I simplify it by doing my multiplication, which would be 4 times 5 is 20, minus 4 times y is 4y. My simplified expression is 20 minus 4y. And again, I cannot add 20 and 4y together or subtract them because they are not like terms. Therefore, 20 minus 4y is my simplified expression. Okay, let's discuss a common error that many students make. And I'm going to use the example 6 times the sum of x and 10. And I'm going to start by saying, well, if x is equal to 2, what would the value of my expression be if I replace the x with 2? And that would be 6 times the quantity of 2 plus 10, and order of operations says do what's in parentheses first. So I would have 6 times 2 plus 10 is 12, and 6 times 12 is 72. So my simplified expression when x is equal to 2 is 72. We're going to do something a little different now with this same example. In this one, I'm going to distribute the 6 to the x and the 10, and then I'm going to say, what would the value of my expression be if x was equal to 2? So I'm going to distribute the 6 to the x and the 6 to the 10, and I get the expression 6 times x plus 6 times 10. And when I simplify it, it becomes 6x plus 60. So at this point, I say, well, what's the value of my expression if x is equal to 2? So I replace in this expression x with the number 2, and I get 6 times 2 plus 60, and 6 times 2 is 12, and 12 plus 60 is 72. Again, it's the same answer as I got in the first example, done a different way, and then done using the distributive property in the second example. Now I'm going to model the error that many students make. And what happens is many students will distribute the 6 to the x, or the first term, but they'll forget to distribute to the second term. They won't distribute the 6 to the 10. So they end up with this as an expression, 6x plus 10. And then if I say, if x is equal to 2, and I say, well, 6 times 2 plus 10, and I simplify that to 12 plus 10. 12 plus 10 is 22. That is not what we got here or here. So this way is wrong. And it's wrong because the 6 was not distributed to the 10. When we talk about distribution, we need to distribute the number on the outside of the parentheses to each of the terms inside parentheses, as we did here in this example. So please be careful when you are distributing that you distribute to all of the terms inside the parentheses. That's the end of our video, and I hope you have learned how to distribute properly.